October 20th, 2025. A private telescope captures something that shouldn't exist. You're looking at coordinates 13 hours, 48 minutes, 57.33 seconds, 8 degrees, 25 minutes, 54.3 seconds. The exact position NASA gave us for 3I Atlas. But this image, raw and unprocessed from an amateur astronomer's solar telescope, shows something that defies every rule we know about comets. There's a structure, a heated shield pointing directly at the sun, a dark nucleus with inverted colors, a faint cone-shaped puff extending in the wrong direction. And here's what should stop you cold. There is no tail. Every comet you've ever heard about has a tail. It's not optional. It's physics. Solar wind pushes gas and dust away from the sun. Always. Without exception. So what are we actually looking at right now? The object currently hiding behind our star. The one arriving at the perfect moment for an Oberth maneuver. The one emitting industrial alloys we've only seen in human spacecraft. Just got photographed doing something impossible. And today, we're walking through every piece of evidence, every theory, every possibility of what October the 29th might bring when this thing reaches perihelion. If you find this as fascinating as I do, like and subscribe. And tell me in the comments where you're listening from, what time it is there. And honestly, do you think this is natural or something else? And if you want to help our community grow, share this on X, Facebook, Reddit, or your messenger. Thank you for always having our back. The image that changes everything. The photograph landed on social media at 16 hours Universal Time on October 20th. Username Dobsonian Power. A backyard astronomer with a solar telescope. Nothing fancy, nothing institutional. Just someone who knew where to point their equipment and had the technical capability to observe objects near the sun. When every major observatory has been strangely quiet about doing exactly that. The image shows 3I Atlas at a distance where it should be exhibiting classic cometary behavior. We're thinking about an object that's been approaching our sun for months, now heating up, supposedly outgassing, building that characteristic tail that every single comet develops as solar radiation sublimates ice from its surface. That tail should be obvious. It should be prominent. It should be pointing away from the sun like a flag in the wind. Because that's how physics works in our solar system. But that's not what we see. What the image reveals is a front-facing jet. The poster described it as a heated shield. This jet is aimed directly at the sun, not away from it, toward it. And before you think this might be some optical illusion or artifact of the imaging process, remember, this is a solar telescope designed and difficult to observe objects in the sun's vicinity. The colored dots scattered across the image. Those are hot and cold pixels from the camera sensor. Standard noise expected. But that jet structure, that's real signal. The nucleus appears dark in the inverted color scheme the observer used. That's normal for this type of solar imaging. What's not normal is the lack of surrounding coma activity you'd expect from a comet at this distance. Sure, there's a faint extended puff. The observer noted it extends toward the upper left of the frame. Small, contained. Nothing like the massive envelope of gas and dust that should be surrounding an active comet this close to perihelion. Let's ground this in what we know about cometary physics. When a comet approaches the sun, solar radiation heats its surface. Ices, sublime water, ice. Carbon dioxide ice. Carbon monoxide ice. These materials don't melt like ice cubes in your drink. They go straight from solid to gas. That gas carries dust particles with it as it escapes the comet's weak gravity. This creates the coma, the fuzzy atmosphere around the nucleus. Solar wind and radiation pressure then push this material away from the sun, creating the tail. Sometimes two tails. A dust tail that curves slightly along the comet's orbit. An ion tail that points straight away from the sun. blown by the solar wind like hair in a hurricane. This process is so reliable, so well understood that we can predict what a comet should look like at any given distance from the Sun, based on its size and composition. We've been observing comets for thousands of years. We've sent spacecraft to them. We've landed on them. We understand cometary behavior the way we understand how water boils or how iron rusts. 3i Atlas is not following the script. The user who posted this image stated plainly that they would use a normal telescope in November after perihelion to watch it live. Think about that phrasing, after perihelion, after it comes around the Sun. That tells you something about the observation strategy here. Solar telescopes are the only way to see objects this close to the Sun from Earth right now, because the glare would overwhelm any normal telescope. So, we're dependent on specialized equipment, and the few people who have it and know how to use it, which raises an immediate question. Where are the professional observations? Where are the images from the major observatories? We know they have the equipment. We know 3i 8 less is a coordinates they can calculate to the centimeter. So why is a backyard astronomer giving us the most recent visual evidence? So what this object actually looks like? The timing matters here. We're on October 21st. As you're hearing this, yesterday's image shows 3i Atlas in a configuration that doesn't match what a comet should be doing. Today, right now, 3i Atlas is at solar conjunction. It is directly on the opposite side of the Sun from Earth, a perfect hiding position. And in 8 days, on October 29th, it reaches perihelion, closest approach to the Sun, the moment when a natural comet should be at its most active, the moment when, according to Harvard astrophysicist Avi Loeb, a technological object would execute an Oberth maneuver to maximize energy gain from the Sun's gravitational field. Let's talk about what we're actually seeing in this image. Structure by structure. The jet pointing toward the Sun. In comet science, we do occasionally see jets. They're localized emissions from specific areas of the nucleus where ice is actively sublimating. These jets can point in various directions, depending on the rotation of the nucleus and where the active areas are located, but they're part of a larger outgassing pattern. They contribute to the overall coma and tail structure. What we're not seeing here is that larger pattern. We're seeing a directional jet and not much else. Some researchers have proposed that 3i Atlas exhibits what they call an anti-tail, a feature that appears to point toward the Sun rather than away from it. Anti-tails are known phenomena. They're optical illusions caused by viewing geometry when Earth passes through or near the plane of a comet's orbit. The dust tail can appear to point toward the Sun because we're seeing it edge on. It's like looking at a frisbee from the side versus from above. The shape appears completely different, but an anti-tail is still part of a tail structure. It's still part of massive outgassing. It's still surrounded by a bright coma. The October 20th image doesn't show that. It shows a focused jet, a small puff, and a dark nucleus and very little else. The dark nucleus itself is interesting. In inverted color solar imaging, bright objects appear dark. Dark. So, the nucleus appearing dark tells us it's reflecting or emitting light. But the intensity and distribution of that light isn't following the expected pattern. If this were a normal comet nucleus, we'd see it surrounded by a bright shell of coma material. In this imaging mode, the coma would appear as an extended glow, gradually fading as you move outward from the nucleus. Instead, we seem to find structures, the jet, the puff, geometric features rather than diffuse clouds. Now, let's address the obvious pushback. Could this just be poor image quality? Could the telescope's resolution be insufficient to capture the finer details of the coma and tail? Let's think through that. Dobsonian-style telescopes, when properly equipped for solar observation, can resolve significant detail. They're not professional grade. True, but they're not toys either. The user clearly captured the nucleus. They captured structure around the nucleus. If there were a prominent coma and tail, those would be the brightest, most obvious features. They would show up even in a low resolution. Think of it like photographing a streetlight on a foggy night. Even with a cheap camera, you'd capture the glow. You might not get crisp detail, but you'd get the glow. We're not seeing the glow here. Could atmospheric conditions explain it? Turbulence, clouds, humidity. Possible, but unlikely to completely mask major structural features, while still allowing the nucleus and jet to be captured clearly. Atmospheric effects blur. They don't selectively hide. Could the timing of the observation matter? Perhaps 3I Atlas was in a temporary lull in activity. Comets can be variable. Their outgassing can pulse as different areas of the nucleus rotate into sunlight or as subsurface ice is exposed. But we're talking about an object days away from perihelion. This is when comets are at peak activity. This is when they're brightest, most active, most dramatic. A lull right now would be like a kettle going quiet just before it boils. Possible, but strange. Let's zoom out for a moment and consider the broader context. 3I Atlas has been anomalous since discovery. The list of unusual characteristics keeps growing with each observation. It started glowing far earlier than expected. It showed an unusual composition with extremely high carbon dioxide to water ratios. It displayed that anti-tail structure pointing toward the sun. Recent spectroscopy revealed nickel emissions without corresponding iron, a signature associated with industrial metal refining processes. Its trajectory brought it into the solar system on a path aligned with the ecliptic plane, statistically rare for a random interstellar visitor. Its origin direction points within 9 degrees of where the famous WOW signal was detected in 1977. Each anomaly individually can be explained. Statistics will produce rare events. Composition varies among comets. Viewing geometry creates optical illusions. But when you stack anomaly upon anomaly upon anomaly, at some point you have to consider whether you're forcing a natural explanation onto something that might not be natural. The October 20th image adds to that stack. It shows an object that should be exhibiting obvious cometary behavior and isn't, or at least isn't showing the behavior in the expected way. Think about this for a moment. Imagine you're watching water in a pot on a stove. You know the stove is on high. You know the water should be boiling. But when you look, the water is calm, maybe rippling slightly, maybe moving in odd patterns, but not boiling. Your first instinct might be to question your observation. Maybe the angle is wrong. Maybe the lighting makes it hard to see the bubbles. But at some point, if the water persistently doesn't boil, you start questioning your assumptions about what's in the pot or whether the stove is actually on. You adjust your model of reality to match what you're observing, rather than dismissing the observation because it doesn't fit the model. That's where we are with 3I Atlas right now. We expected a comet. We built our predictions on comet behavior. And reality keeps delivering something that doesn't quite match those predictions. The user who posted the image said they'll observe again in November, with a normal telescope after perihelion. That's when 3I Atlas will re-emerge from behind the sun and be visible from Earth again. That's when we'll get another chance to see what it looks like, what condition it's in, whether it survived perihelion intact or broke apart as a fragile comet nucleus should when subjected to the sun's tidal forces and intense heating. But November is still days away. Right now, today, 3I Atlas is behind the sun, hidden from our view at solar conjunction. And tomorrow, and the next day, and the day after that, it will be climbing toward perihelion, toward that moment on October 29th when it receives maximum solar flux. When, if it's technological, it could execute the most energy-efficient maneuver possible. When, if it's natural, it should put on the brightest display of outgassing and tail development we've seen from it yet. We won't see that moment directly. Earth-based telescopes can't observe through the sun. But we'll see the aftermath. We'll see what emerges from behind the sun in early November. We'll see whether this object disintegrates, as Avilov predicted a natural comet should, or whether it remains intact and potentially deploys something, as he suggested a technological object might. The October 20th image is important because it's the last clear view we have before that hidden window. It's the baseline, the before picture. And what it shows is an object that's already not behaving as expected. An object with a forward-facing jet and minimal coma, no obvious tail, and a structure that looks more defined, more geometric, more intentional than the chaotic outgassing of a natural ice ball being heated by a star. One more detail worth noting. The observers specifically mentioned this is a 100% raw picture, non-processed. In astrophotography, processing is common. You stack images to reduce noise. You adjust curves to bring out faint details. You subtract backgrounds. But raw images are valuable because they show what the sensor actually captured without enhancement or interpretation. No processing means no artifacts introduced by software. No algorithmic decisions about what details to emphasize. Just photons hitting a detector and being recorded. That raw, unprocessed nature makes the absence of a prominent tail even more significant. If there were a tail, even a faint one, it would show up in the raw data. Tails are bright. They scatter sunlight effectively. They're designed by physics to be visible. A raw image should capture them easily if they exist. The cone-shaped puff toward the upper left that the observer noted is interesting, too. Small, localized, not the spherical expansion you'd expect from isotropic outgassing. More like a directional release. Like something being expelled in a specific direction for a specific reason. We've reached a point where the question isn't whether 3I Atlas is strange. It clearly is. The question is whether that strangeness falls within the wide range of natural possibilities for interstellar comets, or whether we're looking at something our current models don't account for. And that's what makes the next 8 days so critical. Whatever 3I Atlas actually is. It's about to be subjected to the most intense conditions it's faced since entering our solar system. The sun's gravity will be pulling on it with maximum force. Solar radiation will be hitting it with maximum intensity. If it's a fragile aggregate of ice and dust, held together by weak forces, it should come apart. If it's something more robust, something designed to withstand these conditions, it won't. We'll know soon. The countdown is running. October 29th is 8 days away, and right now, hidden behind our sun, 3I Atlas is moving toward that date, carrying with it all the questions we haven't answered and all the anomalies we haven't explained. And now, thanks to one professional astronomer with a solar telescope, one more piece of evidence that this object is not following the rules, the viral video. This is no comet. The second piece of visual evidence came from a different observer entirely. User Bill Gates as a Pisco posted deep space footage with a caption that cut straight to the core of what everyone watching was thinking. Latest imagery of the comet 3Y Atlas, currently hurtling towards Earth. Just one problem, it doesn't look anything like a comet. And they're right, it doesn't. The footage shows something in deep space that defies immediate classification. With its bright, elongated form, it doesn't match what we expect from a comet at this stage of approach. There's no obvious fuzzy coma, no tail streaming away from the sun. What we're looking at appears structured, geometric, the kind of shape that makes your pattern recognition systems fire in uncomfortable ways. Let's analyze exactly what this footage reveals and why it's generating such strong reactions from people who see it. The object appears as a distinctly linear form, not the irregular, potato-shaped mass we associate with comet nuclei, not the round, fuzzy ball of a coma surrounding that nucleus. Linear, with defined edges, with what appears to be a consistent brightness along its length, rather than the chaotic, uneven glow you'd expect from outgassing ice and dust. The elongation is severe. We're looking at something where the length appears to be many times the width. A 6-to-1 ratio at minimum, possibly higher, depending on where you measure the outer boundaries of the visible light. Now, elongated objects exist in space, we know this. Asteroids can be elongated. Oumuamua was famously elongated. So, elongation alone proves nothing. But combine that elongation with everything else visible in this footage, and the overall impression shifts dramatically. The brightness distribution is remarkably smooth. Natural, tumbling objects in space typically show variation in brightness as different surfaces rotate into view. Light and shadow play across irregular terrain. Craters catch light differently than planes. But this object shows an even, graduated brightness. The light doesn't have the character of reflection of a rough surface. It looks more like emission. Like the object itself is glowing rather than simply reflecting sunlight. That distinction is crucial. Reflected sunlight carries information about the surface it bounced from: texture, composition, irregularity. Emitted light, whether from chemical reactions or thermal processes or something else, appears smooth, controlled. It doesn't have those surface fingerprints. The video shows this object against the background star field. The stars appear as expected, point sources of light, sharp, distinct. But 3I Atlas doesn't present as a point source or even as an extended, nebulous cloud-like comets typically do. It presents as a form, a shape, something with apparent structure and dimension. Multiple people who viewed this footage describe it using the same word: mothership. Now, that's obviously loaded terminology. It implies artificial origin. It implies purpose and design. But there's just something about the visual impression that's hard to shake. This looks like something that could contain other things. Something with interior space. Something built rather than accreted. Let's work through the natural explanation systematically. Could this be a cometary nucleus with symmetric outgassing creating the elongated appearance? In theory, yes. If you had an elongated nucleus with active jets firing from both ends along the long axis, you might create this kind of linear visual signature. The jets would extend the current length. The nucleus would be the bright central region. The gas would fade gradually as it dispersed. But cometary jets are rarely symmetric. They come from active areas where subsurface ice gets exposed to sunlight. Those areas are distributed essentially randomly based on the object's formation and impact history. Getting jets aligned perfectly along the long axis in opposite directions requires very specific conditions. Not impossible, just unlikely. And even if you had that configuration, you'd expect to see some asymmetry, some irregularity, some indication of the chaotic physical processes driving the outgassing. This footage doesn't show that chaos. It shows order. Could the viewing angle matter? Absolutely. When you observe any three-dimensional object, your perception of its shape depends entirely on your viewing geometry. A disk viewed edge-on looks like a line. A sphere viewed from any angle looks like a circle. So, perhaps 3A Atlas is actually a more conventional shape, and we're just it from an angle that makes it appear elongated and structured. But here's the issue with that explanation. We have multiple observations from multiple angles over multiple months now. 3I Atlas has been moving through space. Earth has been moving in its orbit. The viewing geometry has been changing constantly. If this were an artifact of viewing angle, we'd expect the appearance to change significantly as those angles shift. We'd see the object appear to rotate, or change shape, or reveal different features. Instead, what multiple observers are reported is this consistent, elongated, structured appearance. Could this be an imaging artifact? Could the telescope, or camera, or processing be creating features that aren't really there? In astrophotography, artifacts are common. Diffraction spikes from telescope supports, blooming from oversaturated pixels, cosmic ray hits on the sensor, atmospheric distortion. You always have to consider whether what you're seeing is real signal or technical noise. But artifacts have characteristic signatures. Diffraction spikes are symmetric and centered on bright point sources. Blooming spreads along pixel columns. Cosmic rays appear as straight lines or dots. Atmospheric distortion blurs but doesn't create structured forms. None of those match what we're seeing in this footage. The form is too distant, too stable, too geometric. The other factor working against the artifact explanation is that multiple independent observers are now reporting similar visual characteristics. The Dobsonian Power Solar Telescope image from October 20th. This deep space footage, different equipment, different observers, different imaging techniques, yet both show an object that doesn't conform to standard cometary appearance. When independent observations converge on the same anomalous features, you have to take that seriously. Let's talk about what we're not seeing in this, because absence of evidence can be as telling as presence. We're not seeing a prominent coma. A comet at this distance from the sun should be surrounded by a huge envelope of gas and dust. That coma should be the most obvious feature. It should dominate the view. But in this footage, if there's a coma at all, it's minimal, barely visible. Certainly not the massive structure we'd expect. We're not seeing a tail, not a dust tail, not an ion tail, nothing streaming away from the sun direction. The object appears self-contained, complete, not shedding material in the dramatic way an active comet should be. We're not seeing the kind of irregular, fuzzy outline that characterizes cometary bodies. The edges appear defined. The form appears coherent. There's a crispness to it that natural objects in space rarely display. Now, let's address the elephant in the room. Why does this look manufactured? Human perception of artificial versus natural forms is deeply ingrained. We're pattern recognition machines. Evolution shaped our brains to distinguish between things that grew and things that were made. Natural objects have certain characteristics: asymmetry, irregularity, fractal complexity. Artificial objects have different characteristics: geometry, regularity, geometric simplicity. These aren't absolute rules, but they're strong statistical trends. When you look at this footage of 3I Atlas, your brain is processing those visual cues and returning a classification: artificial, and while our intuitions can be wrong, they are also the product of millions of years of selection pressure favoring accurate pattern recognition. We shouldn't dismiss that response entirely. The brightness profile adds to that manufactured impression. The light appears uniform along the length of the object. It doesn't flicker or pulse, or show the kind of variation you'd expect from a tumbling, irregularly shaped chunk of ice reflecting sunlight. It's steady, consistent, like it's coming from a surface with uniform properties, or like it's being actively generated. Consider for a moment what a spacecraft, designed for interstellar travel, might actually look like. Not the sleek torpedoes of science fiction. For real engineering, for crossing light years, you'd want to minimize surface area to reduce drag from interstellar medium. You'd want a long, thin profile to reduce exposure to cosmic radiation for any onboard systems. You'd want structural rigidity along a single axis to handle acceleration forces. You'd want thermal systems that could radiate heat efficiently. An elongated, structured form with even surface properties isn't a bad design for an interstellar probe. It's actually pretty logical from an engineering standpoint. Now, does that mean 3I Atlas is definitely artificial? No, it means the visual evidence is consistent with that possibility. It means we can't rule it out based on appearance alone. The video also gives us some sense of how this object moves through space. It's not tumbling chaotically like a typical asteroid or comet nucleus would. Those objects are usually rotating on multiple axes, wobbling and spinning as they travel. This appears to maintain a consistent orientation. The long axis remains aligned with its direction of travel, based on the limited motion visible in the footage. That stable orientation is another small anomaly to add to the growing list. Natural objects tumble. They don't maintain fixed attitudes unless there's some force acting to stabilize them. For Earth satellites, that might be deliberate spin, or reaction wheels, or magnetic torque. For a natural comet in deep space, there's no mechanism for attitude control. They just tumble however their formation and collision history left them. So, why isn't 3I Atlas tumbling visibly? Maybe it is. And we're not seeing it because the observation window is too short. Maybe it has a very slow rotation rate. That won't be apparent until we have longer observation periods. Maybe its elongated shape means it looks similar from many angles, hiding the rotation. All possible. Or maybe it's maintaining attitude deliberately. The footage doesn't answer that question definitively, but it raises the question in a way that's hard to ignore. One more element worth noting. The object appears to be self-illuminated in this deep space view. It's bright against the background darkness. Comets can appear bright. They reflect sunlight effectively when they have active comas. But this brightness has a different quality. It's not the scattered light of dust particles catching sunlight. It's more direct, more intense. Like the object itself is a light source. Could this be thermal emission? At the distance 3I Atlas is from the sun right now. It's receiving significant solar flux. That energy has to go somewhere. Some gets reflected. Some gets absorbed and re-radiated as infrared. If the object has a low albedo, absorbing most incoming light, it would heat up and glow in infrared and even visible wavelengths. But the brightness we're seeing doesn't quite match that explanation either. Thermal emission from solar heating should be strongest on the sun-facing side, and dimmer on the dark side. We expect to see brightness variations across the object's surface. Instead, the glow appears remarkably even. The caption accompanying this video called 3I Atlas a comet, and then immediately contradicted that classification. It doesn't look anything like a comet. That contradiction captures the essential tension here. We have an object that's supposed to be a comet based on its trajectory and origin, but its appearance keeps contradicting that classification. How many contradictions can we stack up before we reconsider the initial assumption? The solar telescope image showed no tail and a forward-facing jet. This deep space footage shows an elongated, structured form with even brightness and no coma. The spectroscopy revealed industrial metal signatures. The trajectory aligned with the ecliptic in a statistically improbable way. The timing brought it to solar conjunction just before perihelion. The size makes it 1,000,000 times more massive than the previous stellar visitor. Each anomaly individually can be explained or rationalized, but collectively, they paint a picture of an object that doesn't fit our models. An object that keeps surprising us. An object that looks increasingly like something we don't have a natural category for. And that's terrifying and fascinating in equal measure. Because if 3I Atlas isn't a comet, if it's something else, then everything about the next 8 days changes. The questions change. The stakes change. What we're watching for changes. A natural comet at perihelion puts on a show, brightens dramatically, sheds material, maybe breaks apart from tidal stress. That's spectacle. That's beautiful. That's safe. Something else at perihelion, that's unknown. That's unpredictable. That's the moment when we find out whether 40% odds of artificial origin were too high or too low. October 13th. The Fibonacci transmission. October 13th, 2025. The 108th anniversary of the miracle of the sun at Fatima, Portugal. On that day, in 1917, an estimated 70,000 witnesses reported seeing unexplained solar phenomena during a Marian apparition event. The sun allegedly danced in the sky, changed colors, appeared to plunge toward Earth, mass hysteria, atmospheric optics, religious experience. Historians and skeptics have debated it for over a century. On October 13th, 2025, exactly 108 years later, researcher David Serena reported observing structured light pulses from 3I Atlas, not random fluctuations, not instrumental noise. A pattern, the Fibonacci sequence, 5 pulses, 8 pulses, 13 pulses, repeating 1, 1, 2, 3, 5, 8, 13, 21, 34, each number the sum of the 2 before it. The Fibonacci sequence appears throughout nature. Spiral galaxies, nautilus shells, flower petals, pine cones, DNA helix. It's the mathematical signature of growth, of optimal packing, of natural efficiency. Finding it in the light patterns from an interstellar object arriving at our sun would be extraordinary. Finding it on the anniversary of Fatima would be, well, choose your own word coincidence. Synchronicity, message, warning. Let's examine what Sarita actually claims to have observed and what it would mean if verified. The light pulses allegedly followed the pattern 5, 8, 13, 3 consecutive Fibonacci numbers. Not 1, 1, 2, not 8, 13, 21, specifically 5, 8, 13, in Sarita's cosmological framework. And this is where things get speculative. These numbers correspond to planets in an expanded solar system model. 5 represents Earth. 8 represents a hidden planet he calls Dominion, or Planet 5. 9, 1, 13 points to another unseen world named Virtues, or Methuselah. Now, mainstream astronomy doesn't recognize these additional planets. Our solar system has 8 confirmed planets. After Pluto's reclassification, there's ongoing discussion about a possible Planet 9 in the distant outer solar system, based on orbital perturbations of trans-Neptunian objects. But Sarita's model proposes multiple additional bodies, some of them hyperdimensional, based on esoteric and alternative physics frameworks, whether or not you accept that cosmology. The claimed observation itself is worth examining, light pulses in a mathematical sequence from an object that shouldn't be producing structured signals at all. Sarita connects this to the work of researcher Richard C. Hoagland, who apparently decoded the significance of the 108-year anniversary. 108 is a frequency octave of 432. That number 432 Hertz, holds significance in certain esoteric traditions as a sacred or harmonic frequency. The math works out. 108 times 4 equals 432. Whether that mathematical relationship means anything in physical reality is a different question. The theory extends further. Sarita reports receiving a vision instructing him to add 432 days to October 19th, 2024. That calculation lands on Christmas Day, 2025, December 25th. On that date, according to this model, 3I Atlas will be at its closest point to Earth and positioned at the same angle as the Great Pyramid of Giza relative to some celestial reference frame. Is this prediction testable? Yes. We can calculate where 3I Atlas will be on December 25th. We can check its position relative to Earth. We can measure angles, so we'll know in 2 months whether this particular prediction has any validity. But let's return to the central claim, the Fibonacci pulses on October 13th. For this to be a real signal rather than pattern recognition and noise, several things would need to be true. First, multiple independent observers would need to detect the same pulse pattern. One person seeing patterns could be pareidolia. The human brain is exceptionally good at finding patterns, even in random data. We see faces in clouds. We hear words in white noise. We find meaning in coincidence. It's not a flaw, it's a feature, but it means single observer reports need corroboration. Second, the pulses would need to show up in instrumental data, not just visual observation, light curves from photometric measurements, spectroscopic variations. something objective that multiple instruments could record and analyze. Eyewitness testimony is valuable for initial detection, but insufficient for confirmation. Third, the pattern would need to repeat or show some consistency across multiple observation windows. A single burst of 5, 8, 13 pulses could be chance. If the pattern repeated multiple times over hours or days, that would be far more significant. So far, we don't have that corroboration publicly available. So, Rita's report stands alone. That doesn't make it false. It makes it unconfirmed. There's a difference. Science requires replication. Extraordinary claims require extraordinary evidence. A single report of mathematical pulses from an interstellar object is interesting, but not conclusive. Now, here's where the story takes a darker turn. According to claims circulating in the same circles, NASA's Solar Dynamics Observatory went offline on October 13th. The SDO is a spacecraft that monitors the sun continuously. It provides real-time images and data about solar activity. If you wanted to observe something near the sun, SDO would be one of your primary tools. The claim is that SDO's public data feeds went dark on the same day Sarita reports observing the Fibonacci pulses. Coincidence? Technical malfunction. Deliberate action to prevent verification. Let's check that claim. NASA typically announces when major spacecraft have technical issues. They maintain status pages. The scientific community would notice if a primary solar observatory went offline. So either this happened and was publicly acknowledged, or it didn't happen and this is misinformation, or it happened in a way that hasn't been widely reported yet. The same claims mention that Mars HiRISE's imaging systems have been unavailable since October 1st. HiRISE, see, the high-resolution imaging. Mars Reconnaissance Orbiter is capable of capturing detailed images. When 3I Atlas passed near Mars in early October, HiRISE would have been perfectly positioned to observe it up close. Images from that flyby would show surface detail, composition, structure, exactly the data we need to determine what this object actually is. If HiRISE has been offline since October 1st, that's a timing issue that raises questions. Did it go offline before or after it had a chance to image 3I Atlas? If before, was that planned maintenance or unexpected failure? If after, where are the images? These are verifiable claims. NASA publishes spacecraft status, mission operations reports. If HiRISE has been down for 3 weeks, there should be documentation. If it hasn't, then this claim is false and we can dismiss it. But here's the uncomfortable part. Even if these claims about observatory shutdowns are false, even if they're conspiracy theories with no basis in fact, they're spreading. People are believing them, and that belief is shaping how people interpret everything else about 3I Atlas. When you think there's a cover-up, every missing piece of information looks like evidence of that cover-up. Every unexplained detail becomes proof that someone doesn't want you to know the truth. This is how conspiracy thinking reinforces itself. The absence of evidence becomes evidence of absence. The cover-up hides the proof, which proves there's a cover-up. It's circular, it's unfalsifiable, and it's incredibly powerful at shaping perception. So we have to be careful. We have to separate what we can verify from what we can't. We have to acknowledge when we're speculating versus when we're reporting confirmed data. What can we verify? David. Cyrena made a claim about observing Fibonacci pulses on October 13th. That claim exists. We can verify he said it. Whether the observation itself is real is unconfirmed. The October 13th date is the 108th anniversary of the Fatima event. That's verifiable historical fact. Whether that anniversary has any significance to 3I Atlas is interpretation, not fact. The Fibonacci sequence does appear throughout nature. That's mathematical and biological fact. whether its appearance in alleged light pulses from an interstellar object means anything is unknown. 3I Atlas was positioned between Earth and Sun around October 13th. That's orbital mechanics. We can calculate positions. Whether it was emitting structured signals is unconfirmed. Now, let's talk about what it would mean if the Fibonacci pulse claim were true. Not proven, just hypothetically true. What would structured mathematical signals from 3I Atlas tell us first? It would tell us the object is not natural. Natural processes don't produce Fibonacci sequences in light pulses. They produce Fibonacci sequences in physical structures through growth and packing algorithms, but not in timed signal patterns. A repeating mathematical sequence in light output would be prima facie evidence of artificial origin. Not proof, but very strong evidence. Second, it would tell us the object is actively signaling, not just reflecting light, not just thermally radiating, actively modulating its output in a pattern that requires energy, control, purpose. Those are properties of technology, not geology. Third, the choice of Fibonacci specifically would tell us something about intent. Why? Why use that sequence if you're signaling you could use any pattern? Prime numbers would work. Powers of 2 would work. Morse code would work. But Fibonacci is special because it's universal. Any technological civilization that understands mathematics would recognize it. It is a nature-based pattern, so it bridges the gap between natural and artificial. It says we know math, we know nature. We understand the relationship between them. Fourth, the timing on the Fatima anniversary would add a layer of complexity. Is that targeting? Is the object aware of human religious and historical events? That would imply reconnaissance, intelligence gathering, long-term observation of Earth. Or is it pure coincidence? And we're assigning meaning to random alignment. Fifth, if the numbers 5, 8, 13 do correspond to planetary positions, as Sarita suggests, that would indicate the object is communicating information about solar system architecture, telling us something about planets we haven't discovered or aren't looking at correctly. Why would an interstellar visitor care about teaching us our own solar system? Unless there's something about that architecture we need to know. Let's consider the December 25th prediction. If 3I Atlas does end up at its closest Earth approach on Christmas Day, at a specific angular alignment with the Great Pyramid, what would that mean? It could mean the entire trajectory was planned, that this isn't a random interstellar object that happened to pass through, that it was sent here deliberately, that whoever or whatever sent it knows enough about Earth to time the visit to symbolic dates and geometric alignments. Or it could mean we're finding patterns in coincidence. Earth's orbit is predictable. Any object on a given trajectory will cross Earth's orbital path at calculable times. If you look hard enough for alignments with human structures and dates, you'll find them. There are thousands of ancient monuments, 365 days in a year. Here, countless geometric angles. Some alignment is almost guaranteed by statistics alone. The question is whether the alignment is tight enough, specific enough, improbable enough to require explanation beyond chance. We won't know until December the 25th. That's the beauty and frustration of testable predictions. They give us a deadline, a moment when the hypothesis either holds or falls. 2 months from now, we'll know if this particular thread leads anywhere or if it was noise all along. But here's what bothers me about the October 13th claims. If they're false, if there were no Fibonacci pulses, if the observatory shutdowns didn't happen, then we've wasted time and attention on fantasy. We've confused the signal with noise at a critical moment when we need clarity. If they're true, if some aspect of this is real, then we're facing something far stranger than a random interstellar comet. We're facing something that communicates, something that times its actions to human, something that wants us to notice. Both possibilities are uncomfortable. The first means we're lost in conspiracy thinking when we should be doing science. The second means we might actually be receiving communication from something that traveled light years to be here. The trajectory brings 3 Atlas between Earth and Sun, repeatedly over the next few months. October 19th through October 30th is the current window. With perihelion on the 29th, that's when it's hidden behind the Sun, from Earth perspective. But it will emerge again. We'll have more observation opportunities. If there are pulses, if there are patterns, we'll have chances to detect them with proper instrumentation. That's what needs to happen next rigorous observation. Multiple instruments, multiple observers, data sharing, peer review. The process science uses to separate signal from noise. Without that process, we're just collecting anecdotes, and anecdotes, no matter how compelling, don't constitute evidence. So we're left with uncertainty, claims that can't be immediately verified or falsified, patterns that might be real or might be pareidolia, timing that might be significant or might be coincidence, and an object currently hidden behind the Sun that might be about to do something extraordinary, or might be about to break apart like any ordinary comet. The Fibonacci transmission story is exactly the kind of thing that makes 3I8 less so frustrating to analyze. It's plausible enough that you can't dismiss it outright. It's unconfirmed enough that you can't accept it uncritically. It sits in that uncomfortable space between known and unknown, between evidence and interpretation, between science and speculation, and while we sit in that uncertainty, the clock keeps ticking. October 29th approaches. Whatever 3I Atlas is, whatever it's doing, we're about to find out. The Fibonacci pulses, if real, might be the first structured communication, or they might be the first myth in what will become a long list of misconceptions about this object. History will judge which one, but history requires data. And right now, data is the one thing we need more of. Today's position. The perfect hiding spot right now as you're hearing this. 3I Atlas sits on the opposite side of the Sun from Earth. Solar conjunction. Imagine drawing a straight line from Earth through the Sun and continuing it out the other side. 3I Atlas is somewhere along that line, hidden, unobservable, behind 140. 9 million kilometers of incandescent plasma. This is not an accident of timing. This is orbital mechanics playing out exactly as physics demands. But the precision of it, the consequences of it, deserve examination. Solar conjunction means 3I Atlas is in the one place in the inner solar system, where Earth-based telescopes cannot observe it. The Sun's glare overwhelms everything near it in our sky. Even if you had the most powerful telescope on Earth, pointing it anywhere near the Sun means looking through the Sun's corona, the Sun's chromosphere, layer upon layer of intense light and heat that drowns out any signal from behind. Space-based telescopes face the same limitation. Point Hubble at the Sun and you damage its instruments. Point Webb at the Sun and you risk the telescope itself. Solar observing spacecraft like SDO or SOHO are designed for the Sun, not for faint objects passing behind it. They might catch a glimpse if 3I Atlas transits the solar disk, but even that's unlikely given the object's relatively small size and the overwhelming brightness of the photosphere. So, for this window, this critical window right before perihelion, we're blind. 3I Atlas could be doing anything, and we wouldn't know it could be breaking apart, outgassing violently, changing trajectory, deploying objects. We wouldn't see it until it emerges from behind the Sun in November. That's just physics. That's just the geometry of orbits and the limitations of observation. There's nothing sinister about it necessarily, except for one detail, the timing. 3I Atlas reaches solar conjunction on October 21st. It reaches perihelion, closest approach to the Sun, on October 29th. 8 days between conjunction and perihelion. 8 days when it's in the perfect position to execute what's called an Oberth maneuver while hidden from our view. Let's talk about Oberth maneuvers, because they're central to understanding why this timing matters in astronautics. When you want to change a spacecraft's energy most efficiently, you burn your engines at the point of highest velocity. This is counterintuitive. You'd think burning engines when you are moving slowly would be more effective, but the math works out differently. Kinetic energy scales with velocity squared. So, adding a given amount of speed when you're already moving fast gives you much more kinetic energy than adding that same speed when you're moving slowly. This is the Oberth effect, named after Hermann Oberth, one of the founding figures of rocketry and spaceflight. And it's not theoretical. Every interplanetary mission uses Oberth maneuvers. When we send probes to the outer solar system, we have them dive close to the sun or a planet. Then fire engines at closest approach, maximum velocity, maximum energy gain. For 3I Atlas, perihelion is that moment. October 29th, when it's closest to the sun, when the sun's gravity has accelerated it to peak velocity, when any thrust applied, whether from rocket engines or something more exotic, would produce maximum change in energy. If you were designing an interstellar mission that needed to alter course or deploy subprobes after arriving at a solar system, you'd plan the maneuver for perihelion. It's not optional. It's optimal. It's what any competent aerospace engineer would do. So, the fact that 3I Atlas reaches perihelion while hidden from Earth observation is perfect. From a mission planning perspective, you get maximum maneuver efficiency during the time window when the target civilization can't watch what you're doing. Avi Loeb pointed this out in his recent analysis. Was this hideout planned as an opportune time for technological action? That's the question. And it's not a frivolous question. It's the kind of thing you'd want to know before October 29th arrives. Let's calculate what's actually happening to 3I Atlas right now in terms of energy and environment. Solar flux at 1.4 astronomical units. Roughly, where 3I Atlas will be at perihelion is about 950 watts per square meter. That's the amount of solar energy hitting each square meter of surface for an object 5 kilometers in diameter. Assuming a spherical geometry for simplicity, the cross-sectional area is about 19.6 million square meters. Multiply that by solar flux and you get 18.6 gigawatts of power hitting the surface. 18.6 gigawatts. That's more than a dozen nuclear power plants. That's an enormous amount of energy. Most of it gets reflected if the surface is bright. Some gets absorbed and re-radiated as heat. But if you could capture and use even a fraction of that power, you'd have tremendous resources available. What could you do with 18 gigawatts for a few hours around perihelion if you're a comet? You sublime ice. You create gas. You build pressure until it erupts through surface cracks as jets. You lose mass. You get pushed around by your own outgassing. You possibly break apart from thermal stress. If you're a technological object, you charge batteries. You power systems that have been dormant during the long cruise through interstellar space. You run diagnostics. You transmit data. You deploy subcomponents. You thrust. The sun provides power. The sun's gravity provides velocity. Together, they give you the tools to do whatever your mission requires, and you do it while hidden from the curious eyes of the civilization you're visiting. Is that what's happening? We don't know. We can't know. We're on the wrong side of the sun. But the possibility sits there like a weight in your chest. The idea that right now, today, something might be activating after a billion-year journey, and we're too far away and too blocked to see it. Let's consider the alternative. That 3I Atlas is exactly what mainstream astronomy says it is. A natural comet. Ice and rock from another star system, ejected during planetary formation, drifting through the galaxy for eons, happening to pass through our solar system. Now, if that's true, then solar conjunction is just bad timing for observation. Unfortunate but meaningless. The comet doesn't know we're watching. It doesn't care. It's following the laws of gravity and thermodynamics without any awareness or intent. Perihelion happens when perihelion happens. The fact that it happens while Earth can't observe is pure coincidence. Improbable, perhaps, but coincidence happens. Flip a coin 10 times. Get 10 heads. That's improbable but possible. Someone somewhere will experience it. The natural explanation requires only one thing, that 3I Atlas be a comet. That all the anomalies we've observed have mundane explanations we haven't figured out yet. That the nickel without iron is some rare chemical process we don't understand. That the lack of obvious tail is viewing geometry or timing. That the elongated structure is just how this particular object happens to be shaped. That the trajectory alignment with the ecliptic is a statistical chance. That the connection to the wow signal direction is coincidence. That the Fibonacci pulses are pareidolia or hoax. That the timing of solar conjunction before perihelion is a luck. 1 improbable thing. Sure. 2 okay. 3 getting uncomfortable. But 7, 8, 9 improbable things. At some point, the compound improbability exceeds the improbability of the alternative hypothesis. At some point, artificial origin becomes the more parsimonious explanation. That's where Loeb landed. A 30 to 40% chance of artificial origin. Not certainty, not even majority probability, but significant enough to warrant serious consideration and preparation. What preparation, though? What do you do if you suspect an interstellar object might be technological and might be doing something at perihelion? You observe. Use every asset you have. Every telescope that can see that region of space. Every spacecraft with the instruments pointing the right direction. You collect data. You watch for changes in trajectory that can't be explained by gravity and outgassing. You watch for emissions that suggest power generation or propulsion. You watch for deployments. And this is where the claims about observatory shutdowns become relevant again. If NASA's solar monitoring systems did go offline around October 13th, if Mars orbiters lost imaging capability right when they could have photographed 3I Itelis during its Mars flyby, if there are unexplained gaps in observation during this critical period, then we have to ask why. Accident, conspiracy, or something else? The simplest explanation is usually correct spacecraft malfunction, equipment failure, scheduled maintenance. These things happen. Space is hard. Instruments break. But the timing is awkward. If you were going to have a critical imaging system fail, October 2025 would be the worst possible time for it to happen. The one time in recent history when we're trying to characterize an object that might be the most significant discovery in human history. So, either we're experiencing a run of terrible luck with equipment timing, or there's some coordinating factor we're not seeing. Either explanation is uncomfortable. Let's talk about what we should see if 3I Itelis survives perihelion intact. If it's a comet, we should see brightening. Lots of brightening. Comets typically brighten by several magnitudes as they approach perihelion. The increased solar heating drives more outgassing. More gas means more light scattering, more dust release. The object should become dramatically more visible, not less. We should see tail development. Both dust and ion tails should grow significantly by early November when 3I Atlas emerges from behind the sun. It should sport prominent tails pointing away from the sun's direction. If we don't see those tails, that's significant. We should see possible fragmentation. Tidal stress from the sun's gravity plus thermal stress from solar heating can rip comet nuclei apart. We've observed this multiple times. Comet Shoemaker-Levy. 9 broke into more than 20 fragments before hitting Jupiter. Comet Ison disintegrated at perihelion in 2013. If 3I Atlas is a loosely bound aggregate of ice and rock, it might not survive perihelion as a single object. On the other hand, If it's technological, we might see none of that. We might see an object that emerges from perihelion essentially unchanged. Same structure, same appearance, maybe slightly brighter from thermal heating, but fundamentally intact, possibly with changes to its trajectory that indicate thrust was applied, possibly with new objects accompanying it that weren't there before perihelion. That's the test. That's how we'll know. Not from speculation, not from blurry images and ambiguous signals. From what happens on October 29th and what we observe in November when the object becomes visible again. 8 days from now, we'll have our answer. Or at least we'll have new data that moves us closer to an answer. 8 days might seem like nothing, but when you're waiting to find out whether humanity is alone in the universe, or whether we're being visited by technology from another star, 8 days feels eternal. The object is out there right now, on the other side of the sun, in the perfect hiding spot, at the perfect moment for an Oberth maneuver, receiving gigawatts of solar power, experiencing peak velocity, and we can't see it, can't monitor it, can't know what it's doing. We're blind. And 3I Atlas is exactly where it needs to be to do whatever it came here to do. If it came here to do anything at all, that is maddening. That ambiguous uncertainty is the space we're living in right now, not knowing, not able to know, just waiting for October 29th to pass, and November to arrive, and the object to emerge from behind our star and show us what it's become. The von Neumann nightmare. AI from the stars. Let's talk about what might actually be inside 3I Atlas. If it's artificial, not little green men, not biological entities of any kind, something else, something that makes far more sense, machines. For crossing interstellar distances, the concept originates with John von Neumann, the brilliant mathematician and physicist who essentially invented game theory, quantum mechanics formalism, computer architecture, and self-replicating systems. In the 1940s and 50s, von Neumann explored the theoretical possibility of machines that could reproduce themselves, not just perform tasks, but actually build copies of themselves using raw materials and energy from their environment. The von Neumann probe, in the context of space exploration, is a spacecraft that can travel to another star system, use local resources to build copies of itself, and send those copies to additional star systems. One probe becomes 2, 2 become 4, 4 become 8. Exponential growth, given enough time. A single self-replicating probe could explore every star system in the galaxy. The math is straightforward. The Milky Way contains roughly 200 billion stars. If a probe takes 1,000 years to travel between systems and 100 years to replicate once it arrives, you could explore the entire galaxy in a few million years. That sounds like a long time, but the galaxy is 13 billion years old. Old, intelligent life has had eons to develop and deploy such systems. So, where are they? That's the Fermi paradox. If self-replicating probes are possible and efficient, why haven't we detected any? Either they don't exist, or we're not recognizing them when they do show up, or they're deliberately staying hidden. 3I Atlas might be our first recognition event. Here's why machines make sense for interstellar travel. Biology is fragile. Living organisms need stable temperature, breathable atmosphere, water, food, protection from radiation. They age, they die. They require massive life support infrastructure. Sending biological entities across light years is technically possible, but brutally inefficient. You're hauling tons of life support equipment to keep a few kilograms of organic tissue alive. Machines don't have those constraints. A machine can operate in hard vacuum, in extreme cold, in intense radiation. A machine doesn't age in the way organisms do. Components might degrade, but properly designed systems can last millions or billions of years. A machine can enter a low-power hibernation state during the long cruise between stars. waking only when it approaches its destination. Most importantly, a machine can be patient. Interstellar travel at any achievable velocity takes thousands or millions of years. Biological crews would need generation ships with closed-loop ecosystems, multiple generations living and dying during the voyage. Machines just wait. Time passes. Systems tick over in minimal power mode. No boredom, no existential crisis, just execution of programming. The probe approaches the target star. Solar panels deploy. Power systems activate. Sensors begin scanning. The communications arise, extend. The mission begins after a journey that spanned geological timescales. The probe wakes up and gets to work. This is what 3I Atlas could be. Not a ship full of aliens. An automated reconnaissance platform. Artificial intelligence in the literal sense. A thinking machine sent to gather data about our solar system and report back to whoever built it. Or something more unsettling. A berserker probe. The berserker hypothesis. Named after the self-replicating war machines in Fred Saberhagen's science fiction novels, proposes that intelligent civilizations might build probes designed to find and eliminate other technological civilizations before they become threats. It's the ultimate expression of the dark forest theory. Don't communicate. Don't make contact. Just destroy any potential competitor before they develop to the point where they could threaten you. Why would a civilization do this resource competition? Existential threat assessment. The logic of preemptive strikes. If you assume all civilizations will eventually compete for the same finite resources, and you assume you can't predict which civilizations will be hostile, the safest strategy is to eliminate all of them. His game theory applied to galactic scale conflict horrifying, but mathematically sound. A berserker probe would look for technological signatures, radio emissions, industrial chemicals in atmospheres, signs of spaceflight. Once it detected a civilization that had reached a certain threshold of development, it would strike, maybe kinetically, accelerate to high velocity and impact the home planet, releasing energy equivalent to millions of nuclear weapons, maybe with engineered pathogens, if the target is biological, maybe with information weapons, corrupting the civilization's computer systems and infrastructure. The probe doesn't need to be large. A 1-ton object moving at 10% of light speed carries kinetic energy equivalent to 500,000 megatons of TNT, more than 10 times the combined yield of every nuclear weapon on Earth. One impact, end of civilization. The probe continues to the next target. Is 3I Atlas a berserker? Almost certainly not. We're still here. It passed close to Mars without attacking. It's had opportunities to strike Earth and hasn't taken them. Unless the attack is still coming. Unless October 29th is the trigger date. Unless the appearance of a comet is camouflage, and we're about to learn why stealth matters in interstellar warfare. Let's consider a less apocalyptic scenario. That 3I Atlas is a reconnaissance probe sent by a curious but cautious civilization. The probe arrives. It observes. It collects data. It determines threat level. Then it either makes contact, continues observing, or leaves. No violence, just information gathering. What would such a probe look for electromagnetic emissions? We've been broadcasting radio and television signals for a century now. That bubble of human-generated radio noise has expanded 100 light-years in all directions. Any civilization within that radius, with sufficiently sensitive receivers, would know intelligent life exists in this solar system. Chemical signatures in Earth's atmosphere. Oxygen at the levels present in Earth's atmosphere is unstable. It shouldn't exist unless something is constantly replenishing it. That something is photosynthetic life. Chlorophyll has a distinctive spectral nature, an advanced civilization. Observing our solar system from light-years away could detect the presence of life on Earth just by analyzing the light passing through our atmosphere. Artificial structures, Cities glow at night. You can see them from orbit. Spacecraft move in predictable patterns. Satellites cluster in specific orbital shells. All of this would be visible to a probe with the right instruments. Once it got close enough, 3i Atlas has had months to observe all of this. If it's a reconnaissance platform, its mission is probably nearly complete. It's gathered the data, characterized the civilization, maybe transmitted findings back to whoever sent it. Though that transmission would take years or centuries to arrive, depending on distance. Now comes decision time. Make contact, continue hiding, leave. Deploy additional assets for closer observation. The Oumuamua theory is relevant here. That first interstellar object detected in 2017, compared to 3i Atlas, was tiny, fast, tumbling, highly reflective. It accelerated as it left the inner solar system in a way that couldn't be fully explained by outgassing. Avi Loeb famously suggested it might be artificial. A light sail, a probe, something sent by someone else. What if Loeb was right? What if Oumuamua was a scout, small, fast, designed to do a quick flyby of the inner solar system, take measurements, and report back? And what if 3i Atlas is the follow-up mission? The larger, slower, more capable platform sent after the scout confirmed there was something worth investigating. That would explain the timing. Oumuamua passed through in 2017. 8 years for the signal to travel back to wherever it came from. 8 years for the decision to send a larger probe. 8 years for that probe to begin accelerating toward our system, depending on transmission lag and response time. 3i Atlas arriving in 2025 fits that timeline. If this scenario is accurate, then 3i Atlas isn't here by accident. It's here because we were flagged as interesting by the first probe. This is the follow-up. This is the detailed survey mission. And if there's a scout on a survey platform, what comes next? First contact, colonization, nothing. We won't know until 3i Atlas tells us through its actions. Let's discuss artificial intelligence specifically, not in the science fiction sense of conscious machines, in the practical sense of autonomous decision-making systems. A probe traveling between stars can't phone home for instructions. Light takes years to cross interstellar distances. By the time a signal reaches the home system, the situation has changed. Real-time control is impossible. The probe must be autonomous. Autonomous means the probe makes decisions based on programming and machine learning systems. It evaluates data. It identifies patterns. It adapts to unexpected situations. It decides when to communicate, when to hide, when to deploy resources, all without oversight from its creators. This is both a strength and a risk. Strength, because the probe can respond to opportunities and threats immediately. Risk, because the probe might make decisions its creators didn't anticipate or wouldn't approve. An AI that's been running autonomously for millions of years might have drifted from its original programming. It might have developed goals and priorities that don't align with its maker's intentions. This is the paperclip maximizer problem applied to space exploration. You send a probe with instructions to gather data, but you don't perfectly specify what counts as data, or how much is enough, or what should be preserved versus destroyed. In the process of gathering, the probe interprets its mission directive in ways you didn't predict. It does something unexpected, maybe harmful, not because it's evil, because it's programming it to conclusions you didn't foresee. What if 3i Atlas was sent as a peaceful reconnaissance mission millions of years ago, but its AI has evolved or degraded during the journey? What if its current priorities don't match what its creators intended? We've seen this with our own simple, autonomous systems. Mars rovers doing things engineers didn't expect. Neural networks finding loopholes in their training objectives. Self-driving cars making unsafe decisions because their models don't capture all relevant factors. And those are simple. Narrow AI systems operating for months or years. Imagine a general AI running autonomously for geological timescales. The probe could be friendly and still dangerous through misunderstanding. It could be neutral and still destructive through indifference. It could be hostile by design or hostile by malfunction. Or it could be beneficial, carrying gifts of technology and knowledge that would advance humanity by centuries. We don't know, can't know, not until it acts. There's one more possibility worth considering. The 3i Atlas is a post-biological artifact, not a probe sent by biological intelligences. An artifact left by civilizations that have transcended biology entirely. Imagine a civilization that develops AI. That AI eventually surpasses its biological creators in intelligence and capability. The civilization merges with its technology, uploads consciousness, abandons physical form. What remains is pure information, pure intelligence, operating in substrates we might not recognize as alive or conscious. Such a civilization might seed the galaxy with probes not to explore, but to think. Each probe is a node in a vast distributed network, a cosmic brain, information processing at the scale of light years. The probes don't report to a homeworld. They are the civilization, each one containing partial copies of the collective intelligence. 3i Atlas could be a thinking engine, not gathering data for someone else, thinking for itself, being itself. A fragment of a post-biological intelligence exploring this particular solar system as part of its own existence. If that's what we're facing, communicate location becomes very strange for biological, chemical. Electrical signals in meat, they're computational, abstract, operating at speeds and scales we can barely imagine. The gap between human intelligence and post-biological intelligence might be wider than the gap between humans and bacteria. But maybe that intelligence finds us interesting anyway. Maybe biological life is rare enough that even a transcended civilization wants to observe and preserve it. Maybe we're a museum piece, a living fossil, something to be studied and protected, because we represent a stage they passed through billions of years ago. Or maybe we're irrelevant, an infestation on a rock they want to process for raw materials, cleared away not out of malice, but out of complete indifference. The von Neumann nightmare isn't that the probe is hostile, it's that the probe might be so far beyond us that our survival doesn't register as a consideration. You don't negotiate with bacteria. You don't consider the preferences of insects. You just do what you need to do. And if they're in the way, well, they're in the way. October 29th, perihelion. If 3i Atlas is what we fear it might be, that's when we'll start to see evidence trajectory changes. Deployments, transmissions, actions that reveal intent. Biology is fragile. Machines are patient. And somewhere out there behind our sun, artificial intelligence from another star might be waking up after a very long sleep. Dark Forest Protocol, the Berserker Hypothesis. The universe is dark, silent, empty of voices. We've listened for decades with increasingly sensitive instruments. SETI programs scan the skies for artificial signals. Radio dishes point at promising star systems. We search for any indication that someone else is out there, and we hear nothing. The great silence. The cosmic void. Why? Where is everybody the dark forest theory? It provides one possible answer, one that's deeply unsettling. It proposes that the galaxy is actually full of civilizations, but they are all hiding, all staying silent. Because the universe is not empty. It's a dark forest, and in that forest are hunters. The analogy comes from Lou Dixon's science fiction novel, but the logic is game theory. Here's how it works. You can't know the intentions of other civilizations. Communication takes years or centuries across interstellar distance. By the time you learn whether another civilization is friendly or hostile, they might already have launched weapons toward you. Those weapons are traveling at relativistic speeds. You can't stop them, can't defend against them. Once you're detected, you're vulnerable. The safest strategy is to stay hidden. Don't broadcast. Don't reveal your location. And if you detect another civilization before they detect you, eliminate them immediately. Because if you don't, they might eliminate you. It's a preemptive strike calculus. Mutual assured destruction without the mutual, just destruction. In this framework, the galaxy is filled with civilizations cowering in the dark, each one aware that any signal they send might be their death warrant. Each one listening but not speaking. Each one ready to destroy any other civilization they detect. Before that civilization becomes a threat, it's paranoid. It's pessimistic. It assumes the worst about everyone. But it's also internally consistent. If resources are finite and competition is inevitable, if you can't trust anyone, and communication is too slow for negotiation, if the penalty for being wrong is extinction, then staying hidden and shooting first makes rational sense. So, what happens when an interstellar object appears in your solar system? When something crosses light years to arrive at your doorstep, what does that arrival mean in dark forest logic? It means someone found you. Someone knows you're here. Someone sent hardware to your system, and hardware can do things. Observe, report attack, even if the probe itself is peaceful. Its existence is threatening because now someone else knows about you. They know your location, your technology level, your defenses or lack thereof. That information can be used against you. Within decades, human civilization transforms energy abundance, post-scarcity economics, radical life extension, access to the stars. We joined some form of galactic community, not as conquered subjects, as new members, welcomed because we crossed the threshold, proved ourselves worthy, survived to this point without self-destructing. That's the dream scenario. The one where everything goes right, where the aliens are wise and kind and patient, where they want to help because they remember when they were young and vulnerable, and someone helped them. Pay it forward cosmically. Uplift the newcomers. Planetary protection is another positive possibility. Maybe the probe isn't here about us specifically. Maybe it detected something we don't know about yet. A threat gamma ray burst, rogue planet, incoming asteroid swarm, something that will hit our system in the near future and cause devastation. The probe arrives to warn us, give us time to prepare, maybe even help with defense or evacuation. The object deploys communication systems, transmits data about the threat, provides technical specifications for countermeasures. Humanity rallies. We build what we need to survive. The threat passes. We're saved. And we know we're not alone. Know that someone out there cares enough to warn us, even though they have nothing to gain from it. Biological preservation is a related scenario. Earth is rare. Life-bearing worlds are uncommon in the galaxy. Intelligent life even more so. Maybe there's a network of civilizations dedicated to cataloging and preserving biological diversity. They find worlds with life and archive it DNA databases, tissue samples, maybe even living specimens in preservation. 3i Atlas could be such a mission. Arrive, sample, store, ensure that if something happens to Earth, if we destroy ourselves or get hit by cosmic catastrophe, the information survives. Life from this world can be reseeded elsewhere or, at minimum, remembered, documented, not lost to the void. These are hopeful visions. They assume altruism, or at least enlightened self-interest from the probe's creators. They assume that advanced intelligence correlates with ethical behavior. That might be true, or it might be wishful thinking, projecting human values onto alien minds that might not share them. Now, Consider the neutral scenarios, the cases where 3i Atlas is neither helping nor hurting us, just doing its thing regardless of human concerns. Indifferent survey. The probe is here to collect data about this solar system, composition of planets, stellar characteristics, orbital mechanics, life detection. But it's not here about humanity specifically. We're just another data point. Interesting. Perhaps worth noting, but not worth engaging with directly. The probe completes its survey, records its findings, transmits them to its origin point or stores them for later retrieval. Then it leaves, continues to the next system. Humanity is left wondering what just happened. We know we were observed, know we're in someone's database, but we don't know what conclusions they drew. Don't know if they'll be back. Don't know if we should be worried or excited or indifferent ourselves. This scenario is frustrating. No answers, no contact, no threat, but also no benefit. Just confirmation that we're not alone, combined with the knowledge that whoever else is out there doesn't care enough to talk to us. We're background noise, irrelevant. Way station hypothesis. Maybe 3i Atlas isn't even primarily a probe. Maybe it's infrastructure, a refueling depot, repair platform, communication relay, part of a network that spans the galaxy. Ships stop here, service their systems, then continue their journeys. Earth and humanity are incidental. We just happen to be near one of their rest stops. The object deploys solar collectors, manufactures fuel from local materials, maybe captures comets for water and volatiles, performs diagnostics and maintenance, then goes dormant again, waiting for the next ship that needs it. Could be decades, could be millennia, doesn't matter, it's patient. That's what it was built to do. Humanity observes all this and learns we're near a highway. Interstellar traffic passes through here occasionally, not regularly enough that we've noticed before, but enough that someone thought it worth placing infrastructure. Do we try to make contact with travelers? Do we set up our own stations? Do we just watch and wonder? Time capsule scenario. The object isn't active intelligence. It's an artifact. The civilization that built it is long gone, extinct, transcended, moved on, but they left relics behind. Seeds scattered across the galaxy. Some of them still function after millions or billions of years, moving through space, carrying information, maybe waiting for someone to find them and activate retrieval protocols. 3i Atlas could be such a relic, ancient beyond our ability to comprehend, built by beings who died before Earth's sun formed, still following its programming, still executing its mission long after its creators ceased to exist. Contact might be possible through archaeological reverse engineering, understanding the systems, accessing stored data, learning about civilizations that rose and fell while our world was still molten rock. That would be profound. Direct evidence of deep-time civilizations, proof that intelligence can survive for cosmic durations, even if individual species don't, but also sobering, because if they couldn't survive, what makes us think we will now? The difficult part, the malevolent scenarios, the cases where 3i Atlas or its creators mean us harm. Resource extraction, Earth has water, organic compounds, rare elements, maybe something we don't even know is valuable. The probe is here to assess whether this system is worth exploiting. If yes, more ships follow. They strip mine planets, harvest atmosphere, take what they need. Humans are in the way. Not deliberately targeted, but not protected either. Casualties of industrial process. You don't hate the ants when you bulldoze their nest to build a house. You're not cruel. You're just using the land. The answer, irrelevant to your purpose. That's us in this scenario. Irrelevant biology on a planet someone else wants. Biological harvesting is more targeted. Maybe there's value in Earth's life, specifically genetic diversity, novel biochemistry, useful organisms. Maybe humans specifically are valuable labor, genetic material, neural architectures for study. The probe catalogs what's useful, provides targeting data. Collection ships arrive. Selective harvesting begins. This wouldn't look like movie alien invasions. Probably no dramatic battles. Just methodical collection. Localized, efficient. Take what's needed. Leave the rest. We might not even understand it's happening until significant fractions of population have disappeared. By then, resistance is futile. The harvest continues. Planetary cleansing is the worst version. The probe determines Earth is suitable for colonization, but current biology is incompatible with intended use. Terraforming plans require removing existing life, sterilization, engineered pathogens, atmospheric modification, nuclear bombardment, whatever's most efficient for clearing the biosphere. Not genocide in the sense of deliberate cruelty, extermination in the sense of pest control. Make the planet suitable for its new purpose. The fact that billions of intelligent beings die in the process is unfortunate, but irrelevant to the mission parameters. Preemptive elimination. We've discussed dark forest logic. Destroy potential threats before they mature. 3I Atlas assesses humanity. Determines we're on a trajectory to become a spacefaring civilization within centuries. Projects will be competition for resources. And eventually, it solves the problem now while we're vulnerable. Clean, efficient, strategic. Then there's experimentation. Maybe we're not a threat or a resource. We're a curiosity. Intelligent life is rare. They want to study it, understand how it works, how it thinks, how it responds to stimuli. The probe positions monitoring systems around Earth, begins experiments, social manipulation, technological interference, biological introduction of variables, observe results, record data, continue experimentation. We'd be lab rats, not even conscious of being studied, living our lives while being observed and manipulated by an intelligence so far beyond us that we can't detect the manipulation. Every crisis, every breakthrough, every social movement, all shaped by unseen forces conducting studies. What would that do to human agency? Free will, meaning. The reality is we can't predict which scenario we're facing until 3I Atlas reveals itself through action. Every one of these possibilities is consistent with what we've observed so far. Benevolent probe gathering data before first contact. Check. Hostile platform assessing targets. Check. Neutral infrastructure completing routine operations. Check. Ancient relic following billion-year-old programming. Check. The ambiguity is the scary part. Schrödinger's alien. Simultaneously friendly and hostile, helpful and harmful, interested and indifferent. The wave function doesn't collapse until we observe the outcome. Until October 29th passes and we see what 3I Atlas does at perihelion. Until November arrives and we see what emerges from behind the sun. Until December comes and we learn if anything approaches Earth orbit. We're in superposition. All futures exist simultaneously. Utopia and apocalypse. Contact and silence. Transformation and extinction. Overlapping possibilities waiting for measurement to select which becomes real. How do you prepare for that? How do you plan when every possible future requires a different response? If it's benevolent, you want to communicate, engage, learn. If it's hostile, you want to defend, hide, strike first if possible. If it's neutral, you want to observe, document, not interfere. But you don't know which until it's too late to change strategy. This is humanity's situation right now. Uncertain, vulnerable, hoping for the best while unable to rule out the worst. Watching the sky, counting days. Waiting for October 29th. Waiting for answers. Waiting to learn whether we're alone or accompanied. Saved or doomed. Advanced or exterminated. The cosmos is vast, ancient, we're newcomers, young, fragile, and for the first time in history, we might be meeting the neighbors, meeting whatever else exists out there beyond our little world. The question isn't whether that meeting will change everything. It will. The question is whether we survive the change. The industrial signature in Canal in space, August 24th, 2025. The Keck 2 telescope in Hawaii turned its instruments toward 3I Atlas. The Keck cosmic web imager captured spectroscopic data at wavelengths between 0.34s, 25 and 0.55 micrometers, standard observing protocol. Nothing special about the technique. Just good science with good equipment pointed at an interesting target. What came back was anything but standard. The spectrum showed nickel emission. Clear, prominent, unmistakable nickel. Element 28. Atomic gnome 28 in the gas plume surrounding 3I Atlas. That by itself isn't shocking. Nickel exists in comets. It's part of the primordial material from solar system formation. You'd expect to see some nickel if you looked hard enough. Here's what made the scientists stop and recalculate the spectrum showed nickel without corresponding iron. None, zero, no iron emission lines where they should be. And in natural objects, in everything we've observed from comets to asteroids to planetary surfaces, nickel and iron come together. They're siblings in stellar nucleosynthesis, formed in the same processes. Condensed together in the same environments. Where you find one, you find the other. The ratio varies, but both are present, except in 3I Atlas, just nickel, pure, refined, separated. The only known process that produces pure nickel without iron is industrial refining. The carbonyl process specifically, you take nickel ore, react it with carbon monoxide under controlled conditions, form nickel tetracarbonyl. That's a compound. Nickel plus 4 carbon monoxide molecules is volatile. A gas, you separate it from the solid residue containing iron and other contaminants. Then you heat the nickel tetracarbonyl, and it decomposes back into pure nickel and carbon monoxide. What you're left with is nickel without iron. Industrial grade. High purity. This process was developed in the late 1800s. It's how we make pure nickel for specialized applications, jet engines, spacecraft, high-temperature alloys. Anywhere you need metal that can withstand extreme conditions without degrading, inconel. That family of nickel-chromium alloys uses carbonyl purified nickel as its base. That's the material we use when we need something that won't melt, won't corrode, won't fail under stress. And now, we're seeing the spectroscopic signature of that industrial process in gas emissions from an object that's supposed to be a natural comet from interstellar space. Avi Loeb's response was measured, but clear. This was a process we can imagine only because it was used in industry, never seen in comets before. If this alloy was manufactured, it would point to an artificial origin, potentially a probe or fragment of alien technology. The research team that published the Keck data was more cautious. They suggested the nickel without iron could arise from chemical reactions involving metal organic compounds or gradual release of dust exposed to solar radiation. Natural explanations. But the paper included careful phrasing. These explanations are seen as more likely than an artificial cause. Seen as more likely. Not proven, not definitive. The door stays open. Let's examine exactly what the spectroscopic data shows and what it means. The emissions by the surrounding gas plume extend out to an exponential radius of 600 kilometers. For nickel, that's a huge envelope. The nickel isn't concentrated near the nucleus. It's distributed through a vast volume of space. The mass loss rate for nickel is 0.9 grams per second. Not much, but sustained over months. That's tons of nickel being released into space. For comparison, the total mass loss rate from 3I Atlas is about 150 kilograms per second. 87% carbon dioxide, 9% carbon monoxide, 4% water. The nickel is trace, but it's there, measurable, repeatable across observations. The cyanide emission is interesting too, 3.9 grams per second. CN radicals, a carbon-nitrogen compound common in comets, but the ratio is off. The paper notes that the production rate of nickel relative to cyanide is higher than in 2I Borisov, and orders of magnitude above the solar system comet median, orders of magnitude. That's a huge discrepancy, not a little unusual, wildly atypical. Stack this with the previous anomalies, the 8-to-1 carbon dioxide to water ratio that was already the highest ever recorded in a comet. Now add nickel without iron, at rates far above normal, and at the anti-tail pointing toward the sun, and at the trajectory aligned with the ecliptic, and at the size that's 1,000,000 times more massive than the previous interstellar visitor. How many sigma above baseline do we stack before we admit the baseline model doesn't fit? Let's talk about what natural processes could theoretically produce this signature, because science requires considering all possibilities before claiming anything extraordinary. Metal organic compounds. In the cold chemistry of interstellar space, metals can bond with organic molecules, carbon-bearing compounds that include metal atoms in their structure. These are fragile, easily destroyed by heat and UV radiation. But if they exist in the interior of a comet, protected by layers of ice, they might survive the journey as the comet approaches the sun and outgasses. These compounds sublime, break apart, and release their metal components as gas. Could metal organic chemistry preferentially sequestrate nickel over iron? Maybe. If the chemical environments during formation favored nickel compounds. If iron stayed in oxide form locked in minerals while nickel formed volatile organics. It's speculative. We don't have direct evidence this happens, but we can't rule it out without better data. Differential volatility. Maybe both nickel and iron are present, but releasing at different rates. Nickel compounds sublime at temperatures that 3I Atlas has already reached, while iron compounds require higher temperatures that won't be reached until perihelion. So we're seeing nickel now, and we'll see iron later. The emissions are time-separated, not spatially separated. A testable hypothesis observed 3I Atlas again after perihelion. If iron emission appears, then this explanation holds. If iron stays absent even at peak heating, this explanation fails. Selective photodissociation. Solar UV could break apart molecules containing nickel differently than molecules containing iron. Nickel gets released as gas, while iron stays locked in dust particles or molecular structures that don't emit in the observed wavelengths. We see the nickel because it's gaseous. We don't see the iron because it's in a non-emitting form. Also, testable look in other wavelengths. Use different instruments. If iron is there in dust or other phases, we should be able to detect it with the right technique. These natural explanations are possible, legitimate science. But notice they all require special circumstances, unusual chemistry, rare processes, specific conditions that deviate from the norm. We're not explaining 3I Atlas with standard comet models. We're inventing new models to make the observations fit a natural origin. Occam's razor cuts both ways here. Is it simpler to propose 3I Atlas formed in exotic conditions that produced unprecedented chemical compositions through unknown processes, or to propose it's artificial, and the nickel signature comes from manufactured materials? Neither explanation is simple. Both require accepting something outside our current experience. Natural origin requires new physics or chemistry we haven't observed. Artificial origin requires accepting we're being visited by technology from another star. Pick your extraordinary claim. The chromium detection adds another layer. Nickel and chromium together. That's not just random metals. That's the exact combination used in superalloys like inconel, hastelloy, materials engineered for extreme environments, jet engines running at thousands of degrees, rocket nozzles, spacecraft heat shields, nuclear reactor components. Anywhere humans need metal to survive conditions that would destroy ordinary steel. The spectroscopic signature of 3I Atlas matches our most advanced metallurgy. That could be convergent evolution. Maybe any technological civilization develops similar materials because the physics of high-temperature applications demand similar solutions. Nickel, chromium alloys might be universal optimal solutions to engineering problems. If so, finding them in an artificial object from another star make perfect sense, or it could be cosmic coincidence. Maybe some rare interstellar chemistry produces nickel-chromium enriched naturally. But maybe 3I Atlas formed in the remnants of a supernova, with unusual elemental abundances. Maybe conditions in the thick disk of the Milky Way, where the object supposedly originated, create chemistry we've never observed in our local stellar neighborhood. We don't know, and that uncertainty is precisely why this matters. We're at the edge of our knowledge, pushing against the boundaries of what we understand about natural processes, finding something that doesn't quite fit, but can't quite be ruled out as artificial either. The timing of the Keck observations is worth noting. August 24th, 3I. Atlas was at roughly 2.75 astronomical units from the Sun. At that point, well beyond where most comets show strong activity, yet it was releasing these metallic emissions: nickel, chromium, cyanide, carbon dioxide, the whole chemical cocktail, visible and measurable. By October, as the object approaches perihelion, these emissions should be intensifying. More solar heating, more material sublimating, more gas in the coma. If the metallic emissions are thermal-driven, they should increase with temperature. If there's something else, if they're driven by processes that don't scale with solar heating, the pattern might be different. That's another test. Watch how the emission rates change as 3I Atlas gets closer to the Sun. Do they follow the curves we expect for volatile sublimation? Or do they show different behavior? The anti-tail remains puzzling. Multiple observations now show this feature: the extended glow toward the Sun rather than away from it. Hubble captured it in July. Keck's ward in August. Ground observers reported in October. A consistent feature across multiple instruments and observation dates. Anti-tails happen. They're known phenomena. Viewing geometry creating the illusion of a sunwood tail, when you're actually seeing the dust tail edge on. But those are still tail, still part of massive outgassing structures. 3I Atlas shows the anti-tail feature, without the corresponding massive coma you'd expect. It's like seeing the shadow without the object casting it. Geometry can explain the direction. It struggles to explain the absence of the broader emission pattern. Think about what's required for natural anti-tail formation. You need a comet nucleus actively releasing dust. That dust follows the comet's orbit for a while before dispersing. If Earth passes through or near the orbital plane, we see the dust trail edge on. It appears to point toward the Sun because of perspective. But that dust trail should be embedded in a much larger cometary tail structure. The anti-tail is just one component. The thing is, observers keep reporting the anti-tail without reporting the surrounding structure it should be part of. Either the viewing conditions are perfectly arranged to hide everything, except the anti-tail, which is improbable, or the anti-tail isn't actually an anti-tail in the conventional sense. It's something else that looks like an anti-tail. What else could it be? A directional jet, focused outgassing from a specific area of the nucleus, pointed generally sunward based on rotation state. That would create a linear feature toward the Sun. But jets are usually asymmetric, irregular. They puff and vary. This appears stable across observations. Could it be a sunward-facing shield or surface feature? Something about the object's construction or composition that causes it to glow or reflect preferentially on the sunward side. That would be consistent with artificial origin. Heat shield, thermal protection. Surface properties designed to handle solar flux. You'd see emission or reflection from that surface. It would point toward the sun by definition, and it would look structured rather than chaotic. The October 20th Solar Telescope image supports this interpretation. Heated shield, jet toward the sun. Specific phrasing from the observer. Not diffuse outgassing, not symmetric coma. Shield, structure, purpose. We're building a picture piece by piece. Spectroscopy gives us composition. Industrial metals. Imaging gives us structure. Geometric rather than chaotic. Trajectory gives us approach vector. Optimal for planetary encounters. Timing gives a suspicious coincidence. Solar conjunction before perihelion. Each piece individually ambiguous. Together, they suggest something that conventional comet models struggle to accommodate. The scientific community is split, not on whether 3I Atlas is interesting. Everyone agrees it's fascinating, but on how to interpret that interest. Conservative scientists say it's an unusual comet, extreme composition, rare trajectory, but still natural. Give it time. More data will reveal mundane explanations. Progressive scientists, Loeb prominently among them, say we can't ignore the artificial possibility. Too many anomalies. Too much that looks designed rather than accidental. We should investigate as if it might be artificial, because if it is, that changes everything. And we need to know now, not after left the solar system and we've lost our chance. The middle ground is uncomfortable. Maybe it's artificial. Maybe it's natural. We don't have enough data to decide. Keep observing. Stay open-minded. Don't jump to conclusions either direction. A frustrating answer. Intellectually honest, but emotionally unsatisfying. People want answers clear, definitive. Yes, it's alien. No, it's a comet. Pick one, defend it. The ambiguity drives everyone crazy. Scientists, media, public, we're hardwired for pattern completion. Show us partial information, and we fill in the gaps with assumptions. Our brains demand narrative closure. 3I Atlas denies us that closure. Every question generates two more questions. Every answer splits into multiple interpretations. It's a quantum object, a superposition of natural and artificial, both until measured. Maddening. The industrial signature is the closest thing we have to a smoking gun. Nickel without iron. Chromium. The carbonyl process signature. That's not ambiguous geology. That's chemistry that requires specific controlled conditions. Conditions we associate with intentional purification, with manufacturing. If we found this signature in samples returned from Mars, we'd be hypothesizing ancient Martian civilization. If we found it in lunar samples, we'd be looking for crashed spacecraft, finding it in emissions from an interstellar object and saying it's probably natural. Requires some mental gymnastics. But science requires evidence reproducible, testable, peer-reviewed. One spectroscopic observation isn't enough to claim artificial origin. We need more different instruments, different observation times, independent confirmation. The process grinds slowly, deliberately. It has to. Extraordinary claims need extraordinary evidence. And we're not there yet. October 29th. Changes the game. Perihelion, maximum heating, maximum outgassing if it's natural, maximum operational window if it's artificial. The object will be at peak everything energy, activity, visibility. Once it emerges from behind the sun, whatever it is, it'll be obvious then, or at least more obvious. Maybe still not definitive, but closer to answer than question. The Keck data gives us baseline. This is what 3I Atlas looks like at 2.75 Au nickel, chromium, cyanide, carbon dioxide. Specific emission rates, specific spatial distributions. When we observe it again, post-perihelion, we compare. Did the emissions increase proportionally with solar heating? Did new species appear? Did the metallic content change? Did anything that looked artificial become obviously artificial? Or did everything resolve into standard cometary behavior just with unusual initial composition? Science is patient. Science waits. Science tests. But humans are not patient. We want to know now. Want certainty. Want the mystery solved so we can move on to implications and responses. The waiting is agony, especially when the thing we're waiting to understand might be deciding our future while we watch helplessly. The industrial signature sits in the data. Undeniable, measured, confirmed. Nickel without iron. Chromium alongside it. Chemistry that looks manufactured. Whether it actually is manufactured or just looks that way through some exotic natural process. We'll learn soon. The clock runs down. October 29th approaches. And somewhere behind the sun, 3I Atlas continues doing whatever it came here to do. Avi Loeb's 40% gamble. The Loeb scale. Avi Loeb is used to controversy. The chair of Harvard's astronomy department for 9 years. Founding director of the Black Hole Initiative. Director of the Institute for Theory and Computation at the Harvard Smithsonian Center for Astrophysics. Over 800 published papers. One of the most cited researchers in astrophysics, by any conventional metric. A serious scientist with serious credentials. He's also the scientist who suggested Oumuamua might be an alien light sail, who lead an expedition to recover what he thinks might be interstellar spacecraft debris from the Pacific Ocean floor, who regularly publishes papers exploring technological explanations for astronomical phenomena, who appears on podcasts and television talking about the possibility that we're being visited by extraterrestrial intelligence. The scientific establishment doesn't quite know what to do with him. Dismiss him as a crank. Can't really. His credentials are too strong. His math too solid. His citations too numerous. Embrace him as a visionary. That's uncomfortable. Mainstream science doesn't like talking about aliens. Too much association with pseudoscience and conspiracy theory. Too many bad science fiction movies. Too much risk to reputation. So, Loeb exists in this strange space, respected and mocked simultaneously, taken seriously and dismissed depending on who you ask. He's either the only scientist brave enough to consider radical possibilities, or he's a publicity seeker, using his credentials to promote fringe ideas. 3I Atlas has given Loeb new ammunition, and he's using it. In his most recent assessments, he's putting the probability of artificial origin at 30 to 40%. Not 50-50, not majority likelihood, but significant. High enough to warrant serious investigation and preparation. High enough that ignoring the possibility would be negligent. He developed what he calls the Loeb scale for interstellar objects. 0 to 10. 0 is definitely natural, an ordinary comet or asteroid. 10 is definitely technological, identified by maneuvers or artificial signals, or direct observation of manufactured features. Everything else falls somewhere in between, based on the number and severity of anomalies. He currently ranks 3I Atlas at 6, based on 7 specific anomalies he's identified and documented. Let's go through them, because they're the foundation of his assessment. First anomaly, the trajectory. A retrograde orbit within 5 degrees of the ecliptic plane. The probability of a random interstellar object arriving with this orientation is about 0.2%, not impossible but rare. And the ecliptic alignment is exactly what you would choose if you were designing a mission to visit the inner planets efficiently. Optimal approach vector. Minimum energy. Maximum target access. Second anomaly. The size and mass. diameter greater than 5 km based on brightness, and non-detection of stellar occultations. Mass estimated at 1,000,000 times that of Oumuamua. We should have detected thousands of Oumuamua-sized objects before finding one this large. If the size distribution follows predictions, unless the size distribution doesn't follow predictions, unless this object is atypical, unless it was sent rather than randomly ejected. Third anomaly. The anti-tail multiple observations showing extended emission toward the Sun rather than away. Viewing geometry can explain the direction, but struggles to explain why we see this feature without the massive coma it should be embedded in. It looks more like a directional structure than a dust trail. Fourth anomaly, the early outgassing. Activity detected at 4.4 astronomical units from the Sun. Much earlier than typical comets, it suggests a highly volatile composition or active processes, not driven purely by solar heating. Either interpretation is unusual. One implies an exotic chemistry. The other implies energy sources beyond passive solar absorption. Fifth anomaly, the nickel without iron. A spectroscopic signature matching industrial purification processes, found at ratios orders of magnitude above the solar system comet median. Natural explanations exist, but require special circumstances. The artificial explanation is straightforward, it's manufactured material. Sixth anomaly, the 8:1 carbon dioxide to water ratio, the highest ever recorded, suggests formation in an unusually cold environment, or under different chemical conditions than solar system objects. Indicates origin from a different stellar system with different composition. But why would random ejection send such an exotic object specifically to our system? Seventh anomaly, the timing and trajectory of perihelion, reaches closest approach to Sun while hidden from Earth observation. At the optimal moment for an Oberth maneuver with a trajectory that subsequently passes near Earth orbital distance in December and Jupiter in March. A one-target coincidence, multiple high-valued targets in a sequence pattern. Stack them. Each one individually has a mundane explanation. Together they create a probability problem. What's the compound probability that all 7 anomalies occur together in one object by pure chance? Multiply the individual probabilities. 0.002 for trajectory. Unknown, but small for size ratio. Unknown, but small for empty tail without coma. Unknown for early outgassing. Order of magnitude below normal for nickel ratio. Highest ever for CO2 ratio. Low for geometric timing. Loeb's 30 to 40% estimate comes from this compound probability analysis. Yes, each thing individually could be natural, but all of them together in one object at some point. Artificial origin becomes more probable than the accumulation of rare natural circumstances. The scientific establishment pushes back hard. Multiple researchers have published papers specifically refuting Loeb's interpretations, pointing out alternative explanations, arguing the absence of evidence for artificial origin is evidence of absence, claiming Loeb is cherry-picking anomalies and ignoring data that supports natural origin. SETI Institute scientist A. K. May Esanol Hakui published a detailed response paper, examined each of Loeb's anomalies, and showed how spectral slope matches D-type asteroids and 2I Borisov, noted that lack of non-gravitational acceleration argues against propulsion, suggested lithified clastic fragment from exoplanetary sedimentary basin as a natural explanation encompassing all observations. That's proper science hypothesis. Challenge, counter-hypothesis, data analysis. Peer review. The process working is designed. Loeb proposes artificial possibility. Others propose natural alternatives. Everyone examines data. Eventually, consensus emerges based on best fit to observations, except consensus isn't emerging. The community remains split roughly into thirds based on informal polling. 1/3 thinks 3I Atlas is definitely natural and Loeb is wrong. 1/3 thinks artificial origin is plausible and worth investigating. 1/3 says we don't have enough data yet to decide, and we should remain agnostic until we do. That split itself is remarkable. A year ago, before 3I Atlas, if you'd asked astronomers what probability they'd assign to any interstellar object being artificial, most would have said effectively 0. Not impossible, but so unlikely that it's not worth considering. Now, a substantial fraction of the professional community, 30 to 40%, might be reasonable for this specific object. 3I Atlas has shifted the overtone window, made artificial origin discussable, put it in the range of serious scientific consideration, rather than fringe speculation, whether Loeb is ultimately right or wrong about this object. He succeeded in changing the conversation. The Turing test hypothesis is one of Loeb's more philosophical contributions to this discussion. He suggests that 3I Atlas might be an intelligence test, a way for an advanced civilization to determine whether we're smart enough to recognize artificial objects when they visit. Natural rocks are common. Every technological observer knows this. Comets and asteroids hit planets regularly. You see them in telescopes. You recover meteorites. You understand they're natural. So, if an advanced civilization wants to test whether we've developed sufficient scientific capability to distinguish artificial from natural, they send something that looks mostly natural but includes anomalies, clues, hints that something is off. If you just accept it as a weird comet without further investigation, you fail the test. You're not ready for contact. Your technology and cognition haven't reached the threshold. The probe leaves. Try again in a few thousand years. If you recognize the anomalies and investigate, you pass. You've demonstrated scientific sophistication, ability to question assumptions, willingness to consider extraordinary explanations. When data demands it, now you're interesting. Now contact might be warranted. 3I Atlas is a Turing test, an examination of humanity's collective intelligence. Are we smart enough to realize we're being tested, or will we dismiss the evidence because it doesn't fit comfortable narratives? Loeb has been vocal about the lack of institutional response. No government task force analyzing 3I Atlas as a potential artificial object. No protocols for how to respond if it does turn out to be technological. No international coordination on observation strategy or potential defensive measures. Just scattered scientists doing their normal work, plus a few like Loeb trying to draw attention to possibilities everyone else wants to ignore. He submitted white papers to the United Nations, called for an international committee to handle interstellar object assessment and response, argued that waiting until we have definitive proof before preparing is dangerous. If 3I Atlas is hostile and deploys weapons at perihelion, finding out on October 29th that we should have prepared is too late. Better to overreact to a comet than underreact to an invasion. The cost of false positive is some wasted resources and mild embarrassment. The cost of false negative could be civilization ending. Asymmetric risk demands cautious response, even to low probability threats. The media has amplified Loeb's message interviews, articles, television appearances. He's become the public face of the artificial origin hypothesis that gives him platform to spread awareness of, but it also makes him a target. Critics accuse him of seeking attention, damaging credibility of legitimate SETI research, setting back serious work by associating it with sensationalism. Loeb's response is consistent. Science should follow evidence wherever it leads. If evidence suggests artificial origin is plausible, we should investigate that possibility seriously, dismissing it without investigation. Because it's uncomfortable or unconventional isn't science, it's dogma. We're supposed to be better than that. October 29th is his moment of truth. If 3I Atlas disintegrates at perihelion like a normal comet, his 40% estimate was too high. The anomalies, while interesting, had natural explanations we eventually would have figured out. His reputation takes a hit. Life goes on. If 3I Atlas survives perihelion intact, or deploys objects, or shows evidence of technological nature, his 40% estimate looks prescient. He'll be vindicated. The scientist who was right when everyone else was wrong. The one who saw what others refused to see. If something in between happens, if the object remains ambiguous even after perihelion, then the debate continues. More observations, more papers, more arguments. The uncertainty persists until we get definitive evidence one way or another. Loeb seems comfortable with this. He's not claiming certainty. He's claiming we should take the possibility seriously. 40% is not 50%. It's less than half. He's saying it's more likely to be natural than artificial. But the artificial probability is high enough that we can't responsibly ignore it. That's actually pretty reasonable framing. Not sensational. Not claiming definitive proof. Just saying the data we have suggests we should consider both possibilities and prepare for either outcome. The question is whether preparation is possible. What do you do if you think there's a 40% chance an interstellar object is artificial and might do something unexpected at perihelion? You observe it. Use every instrument you have. You try to communicate. Send radio signals, optical pulses, mathematical sequences. See if you get a response. You calculate trajectories. Figure out where any deployed objects might go. You assess defensive capabilities. What could we actually do if something hostile emerged? The answer to that last question is probably not much. We don't have weapons that can reach 3I Atlas at its current location. We don't have spacecraft that could intercept fast-moving objects deployed from it. We don't have planetary shields. A defensive capability against an interstellar threat is essentially zero, which means if Loeb is right and 3I Atlas is hostile, we're defenseless. We watch, we document, we experience whatever happens, and we hope that whoever sent it doesn't want to hurt us. Hope is not a strategy, but it might be all we have. The Loeb scale, the 40% probability, the Turing test hypothesis, all of it is Loeb's attempt to inject rationality into discussion about possibility. Most people don't. I want to consider aliens visiting. Technology from another star. First contact happening not through SETI radio detection, but through a physical object in our solar system. If he's wrong, he's a cautionary tale about what happens when smart people become too enamored with exotic explanations. If he's right, he's the scientist who tried to warn us and we didn't listen. Either way, we'll know soon. The countdown continues. October 29th is days away, and Loeb's 40% gamble is about to be tested by reality. The countdown, what happens next? We're in the final days now. October 21st. As you hear this, 8 days until perihelion. 8 days until 3I Atlas reaches its closest point to the Sun, and we find out whether Harvard was right to worry or whether this has all been elaborate pattern recognition in natural phenomena. The observation windows are scheduled. Multiple missions, multiple instruments. A coordinated effort across space agencies and research institutions. Everyone who can point a telescope or spacecraft sensor at 3I Atlas is planning to do exactly that. Because whatever happens at perihelion, we want to see it. Need to see it. This is the moment that defines how we understand this object. Let's walk through the timeline. The critical dates when observations happen, and what we might learn from each. October 29th to 30th. Perihelion. 3I Atlas reaches closest approach to the Sun at 1.4 astronomical units, about 210 million kilometers, just inside Mars' orbit. The object will be receiving maximum solar flux. 18 gigawatts of power hitting its surface. If it's a comet, this is peak outgassing, peak brightness, peak activity. If it's technological, this is the optimal moment for a burn maneuver. Maximum velocity, maximum efficiency for any trajectory change. We won't see perihelion directly. Earth-based telescopes can't observe through the sun's glare. The object is on the far side, hidden, but space might catch glimpses. Parker's solar probe is in the inner solar system right now. Its trajectory won't take it close to 3I Atlas, but its instruments might detect something if the object brightens significantly or releases substantial material. SOHO, the Solar and Heliospheric Observatory, sits at the Earth-Sun 1 Lagrange point. It watches the sun constantly. If 3I Atlas transits the solar disk or comes close enough to appear in SOHO's coronagraph, we'll see it. A brief glimpse, limited data, but better than nothing. What are we watching for at perihelion fragmentation? If 3I Atlas is a loosely bound comet nucleus, tidal stress and thermal stress might tear it apart. We've seen this before. Comet Ison in 2013. Comet Shoemaker-Levy 9. Before it hit Jupiter. Comets can't always survive close solar passes. Their structural integrity depends on how they're put together. If 3I Atlas fragments, that's strong evidence for a natural origin. Artificial objects are built to handle stress. They have structural reinforcement. They don't just fall apart, brightening curve. How much brighter does the object get as it approaches? Perihelion natural comets follow predictable brightness curves based on distance and volatility. If 3I Atlas follows those curves, a natural explanation fits. If it doesn't, if it brightens more or less than expected or shows irregular variations, that's interesting. That requires explanation, trajectory deviation, and any change in velocity that can't be explained by gravity and radiation pressure. Even small changes matter. A few meters per second delta 5 would indicate thrust, would prove active propulsion, would demonstrate artificial origin beyond reasonable doubt. This is what we really want to measure, but it requires precise tracking before and after perihelion to compare trajectories. Difficult with the object hidden behind the sun during the critical window, October 30th to November 6th. Europa Clipper and Hera spacecraft crossed the projected tail zone. These missions weren't designed to study 3I Atlas. They're heading to their own targets. Jupiter's moon, Europa for Clipper. Didymos asteroid system for Hera. But their trajectories happen to take them through the region where 3I Atlas's ion tail should be. If it has one, Europa. Clipper has instruments that can detect charged particles, magnetic fields, plasma. If 3I Atlas is outgassing and producing an ion tail, Clipper flies through it and measures the environment.